All right, so continuing from the first part. So in this reaction now, in this video, we are going to assess the effect of changing the temperature and equilibrium. So the first video was about changing concentration. This one is about changing temperature. So just remember, whatever you do to a system at equilibrium, then the equilibrium is going to do the opposite to counteract that change. So in this case, if we increase temperature, the system or the equilibrium is going to shift in a direction to counteract it, which is to decrease it. All right. So you do one thing, the system do the next. So you go up, or you allow the temperature of the system to increase, then the system will ensure that the temperature goes back down. All right. You turn up the temperature, system turns it down. But how it turns it down is by shifting the position of equilibrium. All right. So if you are going to assess temperature first, you need to look at what you are given. So you will get a delta H value at the end of the equation. It might be exothermic or endothermic. So let us say it's negative 100 kilojoule per mole. All right, so this is the reaction. I want to know. All right, let me put back some questions on the board. All right, so again, we will be interested in the position of equilibrium if we increase the temperature or decrease it. So what do you need to know so far? Whatever the sign is that you get at the end of the equation, it is for the forward reaction. So you were given a negative sign, right? So that's exothermic. All right, so again, whatever sign you get here, that is for the forward reaction. So that means this reaction going forward, that is an exothermic reaction. And as we know, with an exothermic reaction, we will get an increase in the temperature. All right. All right, so that is our forward reaction. It is exothermic, and so the temperature will increase. Now, the reverse reaction is going to be the opposite. It is going to be endothermic. Which means that the temperature will decrease. So what you need to know, right? Whenever you interfere with the system by changing the temperature, the system is going to counteract it by either shifting to the left or to the right. It will shift to the left if the counteraction is to increase the temperature. Sorry, it will shift to the right if it needs to increase the temperature. And the equilibrium will shift to the left if the counteraction is to decrease the temperature. So look, the first question says, state the direction the equilibrium will shift if the temperature of the system is increased. So if we increase the temperature of the system, that means the stress is that we increase the temperature, all right? So we interfered by changing the temperature, by increasing it. So that means the counteraction that the system will do is to decrease the temperature. How it will do that? Which direction results in a decrease in the temperature? It is moving the equilibrium to the left-hand side because that is the side that is endothermic. So whatever you get here, that is for the forward reaction. The reverse reaction is the opposite. So forward is exo, that means reverse is endothermic. So the counteraction is to decrease the temperature. So the equilibrium must shift to the left-hand side. All right. And it's that simple. On the other hand, it says state the direction the equilibrium will shift if the temperature is decreased. So the new stress is that the temperature decreases. All right, so temperature decrease, that means to counteract that, the system needs to increase the temperature. All right, and to increase it, as we can see, the forward reaction is exothermic. So going to the right-hand side is exothermic. And so the system will have to shift to the equilibrium will have to shift to the right. Okay. So if the temperature decreases, the system will want to increase it. And it will do that by shifting the equilibrium to the right. Because notice, if the forward reaction, which is the one that goes to the right, when that reaction is favored, it's an exothermic process, and any exothermic reaction means there will be an increase in temperature. And so that is it for temperature. What we could also ask, right? If you increase the temperature of the system, what will happen to the amount of A? So again, just pay attention to where the equilibrium shifts. If it shifts to the, all right, which one? Let's go up top. The equilibrium shifts to the left, all right? That means anything on the left will increase, anything on the right will decrease. So in our first scenario, all right, scenario 1, this is what happens. All right, so the answer to that, the equilibrium, temperature is increased, right? Equilibrium shifts to the left. Once it goes to the left, the concentration of A and B increases, concentration of C and D decreases. All right, so if they give you this reaction and they were like, how could you change the temperature, right, to increase the amount of products, or let's say to increase the amount of reactants? You would know that if you want the equilibrium to shift to the left, you need to want the counteraction to be to the endothermic side. So the only way it is coming to the left-hand side is if it is trying to decrease the temperature. So it will only move to the left when it is trying to decrease the temperature. And it will only decrease it if it is counteracting an increase in temperature. So if you want to increase A and B, you need to increase the temperature so that when the system counteracts that, it is going to shift to the left-hand side to decrease the temperature. In decreasing the temperature, it will produce more of A and B. All right. In part 2, now, when we decrease the temperature, the equilibrium shifts to the left. Once it shifts to the left, that means the concentration of C and D increases, and the concentration of A and B decreases. So all I need to do is look at where the equilibrium shifts. Wherever it shifts to, the substances on that side will increase. Wherever it is shifting from, the substances on that side will decrease. And so that is it for temperature. Right, we're going to move on to pressure now. So it's concentration, temperature, and pressure. All right, so now it's time to look at the effect of pressure. So what you need to know, right? When you're dealing with pressure, as you can see, I've inserted some state symbols. So when it comes to pressure, we're only dealing with gases, all right? The more moles of gas you have present, the higher the pressure. The fewer moles, lower the pressure. So you can compare both sides of the equation and see which side have more moles. So in our current equation, we have 1 mole of C and 1 mole of D. Both of them are gases. So we have 2 moles on the right side. All right. We have 1 mole of A, which is a gas, 2 mole of B, that's aqueous, it's a solution. So on the left-hand side, we only have 1 mole of gas. So clearly, the right-hand side, it has more moles of gas, all right? The side with more moles, that has a higher pressure. So which means that to increase the pressure, all right, all right, so remember, the system will want to counteract what we are doing. So if we decrease the pressure, it will want to increase the pressure. And it will increase it by shifting the equilibrium to the side with more moles. In this example, it would be the right-hand side. And if the system wants to decrease the pressure, it will shift to the side with fewer moles. In this case, the left-hand side. So the question for you now, in which direction will equilibrium shift if the pressure is A increased? So you can pause the video and answer it. And then for part B, where will it shift if the temperature is decreased? So for part A, the stress is that the pressure increases. So the counteraction by the system would be to decrease the pressure. And so for it to decrease the pressure, the system will shift to the side with fewer moles. When you compare the left and the right, the left has fewer moles. So the equilibrium will shift to the left. All right. When it shifts to the left, we can also look at what happens to the concentration of the substances. Once the equilibrium shifts left, concentration of A and B increases. Concentration of C and D increases. So whenever you change temperature and pressure, they can still ask you about the concentration of the substances, because once equilibrium shifts, the amount of substances on both sides is going to change. One will increase and one set will decrease. All right, so that's what happens if we should increase the pressure. System wants to decrease it, it shifts to the side with fewer moles, which is the left-hand side. Once it shifts, concentration of A and B increase, C and D decrease. For part B, if the pressure decreases, so the stress is that pressure decreases. All right, so we would have decreased the pressure. The system will counteract it, all right, by increasing the pressure. How it will do this is shift the equilibrium to the side with more moles. In this case is the right-hand side. So equilibrium shifts to the right. If it shifts to the right, the concentration of C and D will increase as a result. And the concentration of A and B decreases. All right. So that is how each of the factors affect the equilibrium. The other videos on equilibrium will be of past paper questions. If you have any question, leave it in the comment section. All right, so this is just a summary of what we did for the concentration. You have the summary there. If you increase concentration of the, all right, so for concentration, these two arrows, it shows you what happens when equilibrium shifts to the right. And these two, what happens when equilibrium shifts to the left. For pressure, just remember, once it increases, it shifts to the side with fewer moles. And once it decreases, it shifts to the side with more moles. For temperature, if we increase the temperature, the equilibrium shifts to the side, it shifts to the endothermic side. And if we decrease the temperature, it shifts to the exothermic side. And just remember, wherever equilibrium shifts, anything on that side will increase. So if it shifts to the right, whatever is on the right, it will decrease, it will increase. And wherever it is shifting from, the substances on that side will decrease. So if it is shifting from the left side to the right, whatever is on the left will decrease. All right, so that is it for the Chatelier's principle.